Today we will be working on subtracting fractions and mixed numbers with like denominators. We are going to first start out with a model on how to do so before releasing students to work with the standard algorithm. So in this example, we have 2 and 2 fifths minus 4 fifths. When we are modeling this, we have 2 wholes and 2 fifths. Kids might be able to visualize what 2 fifths looks like. This part might not be hard for them. However, 2 wholes being modeled like this might be quite a challenge. Remind students that because the unit that we are working with in this question is fifths, all of our fraction models should be broken up into fifths. So even though the entire whole is shaded in, we need to partition it into fifths, 5 different parts, okay? So we have 2 wholes and 2 fifths, and then the question asks us to take away 4 fifths. So we would go ahead and cross out 1 of the fifths, 2 of the fifths, 3 fifths, and 4 fifths. Once we do that, we are actually left with an entire whole that is still shaded. And instead of the one that was originally shaded as well, now we have only 3 out of 5 of them that are shaded, leaving us with an answer of 1 and 3 fifths. When it comes to the standard algorithm, the strategy that we are going to use today is to rename fractions by creating fractions that are larger than 1. And so, same example, 2 and 2 fifths take away 4 fifths, except we are going to change 2 and 2 fifths from a mixed number to a fraction that is greater than 1. Students can do this a couple of ways. They can use, They can use a number bond and say, okay, well, if I'm working with 2 wholes as fifths, that would be 10 fifths. And then I have another 2 fifths, giving me a total of 12 fifths. Right? So they've just renamed this mixed number as a fraction that is larger than 1. Another way students may have learned how to do this is by multiplying the denominator with the whole number and then adding the numerator. So 2 times 5 gives us 10, plus 2 gives us 12 fifths, which was the same answer we had for the first strategy, right? So instead of 2 and 2 fifths, we are now working with 12 fifths. 12 fifths take away 4 fifths gives us 8 fifths. And then we would have to rewrite it back as a mixed number. 5 goes into 8 one whole time. There's 3 left over, and 5 is our denominator. So regardless of whether students are feeling comfortable using the fraction model or the standard algorithm, we want to make sure that they're able to have a strategy that they are fluent in when it comes time to solve these types of questions. So I have provided you with both strategies for your exemplar. You will take 5 minutes modeling for students how to do questions 1 and questions 2. And then, questions 1, 2, and 3, sorry. And then you are going to launch them into partner practice for questions 4 through 14 for 10 whole minutes before they start their exit ticket for 5 minutes.